Hi. Welcome to Geometry Review. Okay, so Chapter 8 first. Pythagorean theorem. Do we know what that is?
Yes.
Tell me it.
A squared plus B squared equals C squared.
Okay, so our Pythag theorem, THM for theorem, Pythag for Pythagoras, okay, is A squared plus B squared equals C squared. Cool. That's important. You should know that one. I'm not giving that to you for free. Excuse me. Thank you for that Mountain Dew, Megan. Solve for the missing side. So what we're going to do is we're going to use this thing with right triangles. And this only works with right triangles. Okay? We're going to use this thing to find the missing side. So C is always your hypotenuse. It has to be the hypotenuse because we're adding up the two other sides, side A and side B. And we're getting this thing. And if you add two things together, it makes a bigger thing, which means these two things are smaller than that, which means this is your hypotenuse. Do we understand that C is the hypotenuse always and always? Okay, good. So we've got this. So if I gave you a triangle, here's your problem over here. I'll do it in blue. Okay, here's the problem. I give you a right triangle, and I give you that this guy is equal to 4, and this guy is equal to 3. Can you find the missing side? Okay, and I'm calling it X. Really, we know that's actually C because it's the hypotenuse. It's across from the 90-degree angle. Big angle has the big side. Cool. So, can you do it? Maybe you have this as a special 90-degree triangle memorized. It's not one of our special right triangles. It's just like a perfect Pythagorean triangle. It gives you all nice, easy numbers. So if you don't have that memorized, what you would do is you'd use Pythag. You plug in 3 for A, or I guess I labeled that B. So you plug in 4 for A, doesn't really matter. 4 squared, always practice safe X. 3 squared equals X squared or C squared, however you want to label it. It's this guy right here. Okay, so these are all squared. We can simplify this. 4 squared is equal to 16. And 3 squared is equal to 9. So we get this. We can simplify that. 16 plus 9 is 25. It's way funnier than 24. All right, equals C squared. So now we know what C squared is. C squared is 25. But we don't care what C squared is. We want to know what regular old C is. So how do we get C squared to be C?
Square root it.
Square root both sides. So here's what we're going to do. We're going to put a square root there and square root there.
Can we just do that on a calculator for the test?
You absolutely can. And C squared with a square root on top, they annihilate, right? We're just left with C. Whereas 25 squared, well, the square root of 25, if you don't know it off the top of your head, you can do this. Square root of 25. Is this a prime number? No. So what are the factors of 25? 5 and 5. Also 5 and 1, or 25 and 1, but that doesn't get us anywhere. So 5 and 5. Are these prime?
Yes.
Yes. So both of these guys are in jail. 5 times 5 is the same thing as 25, which is why we didn't change anything. We just rewrote it, right? Okay. If what you have in here doesn't equal what you originally had, then you change the problem, and you aren't allowed to do that. I make the problems, you solve them, right? You don't make the problems and then make, if you were to make your own final, it would not be a very good final. So when we have two in jail, okay, two guys that can team up, they can get out. Unfortunately, the slow friend always dies, and only one of them gets out, with no one left in the jail. If there's no one left in the jail, we demolish it, right? Wasting taxpayer money. So he gets out, and we're left with 5. However, you know that whenever we take a square root, there's a positive and negative answer. There has to be, right? A square root is basically asking what times what gets me this, right? You said 5 and 5. Negative 5 and negative 5 also work. So we've got a positive or a negative answer. But we are dealing with real triangles. This is a real triangle. I drew it myself. Okay?
Beautiful.
Thank you. Okay? So if we're dealing with real things, we can't have a negative length, right? You can't run a negative mile. Even if you do, you just did it really inefficiently, right? You still ran a mile. So this is length 5, not length negative 5. So x in this case, our C from our Pythagorean triangle, is 5. Got a couple of those on there. In fact, you have 2 where you have used Pythag to solve for the missing side. Or if you really like trig, you could use trig for those. Your choice. So let's get rid of these. let's talk about simplifying roots. Well, we kind of just did that, right? So if I give you a square root, like this, you know that's as simple as it gets because 3 breaks down into 3 and 1 only, and these guys are all prime. So yeah, nothing you can do. Root 3 is the answer. But if I give you something like this, how about no, let's do 210. Woo! Big number. Is 210 prime? No, we can see it's divisible by 10, divisible by 2, divisible by 5, right? We got a lot of options. I'm going to divide it by 10 because 10s are easy. If this is 10, this is what? 21. 21 times 10 is here. Are these prime?
No.
No. 21, it breaks down into
3 and 7.
7 and 3, 3 and 7, same difference. And 10 breaks down to
2 and 5.
2 and 5, or 5 and 2. Are these all prime numbers?
Yes.
Yes, they are. So they're all prime, they're good, and we put them in jail. 7, 3, 2, 5. If 7 times 3 times 2 times 5 doesn't get you 210, then you goofed, right? You changed the problem. Don't change the problem. Go back and check your math up here. But it does. 7 times 3 is 21. 2 times 5 is 10. 10 times 21 is 210. Do it on your calculator or whatever, right? Now, we got to get these guys out. Can we get anybody out of here? Are there any doubles here? Nope. So they're stuck inside. So again, this is simplest form. If there was an extra 7 in here, and I'm changing the problem, and that's okay, right? Then there are duplicates. So these guys bust out, but the slow friend dies, and we have this on the outside. 7 root 3 times 2 times 5, which we can simplify to 7 root 3 times 2 is 6 times 5 is 30. Plus or minus. Okay? So again, that's if this guy was different. Let's say he was, you know, whatever. You get the idea. I changed the number. I put another guy in here to show you an example. Cool. I hope it was okay that I'm erasing this. Yell or scream or whatever you want to do to get my attention to stop me from doing that. Last thing with simplifying square roots. If I give you this, we know this is not simplest form, right? Root 3 is fine. It's just where he is, right? You're in the wrong location, okay? We got to get him to the right side of town. So to do that, what we do is we multiply by root 3 over root 3. We take the bottom, we put it in the top and the bottom and multiply, okay? If that was root 7, we do root 7, root 7. If that was root 35, it'd be root 35, root 35, whatever it is, okay? And then when we do this, it's okay because the same number over the same number is just 1. So we're only multiplying by 1, and that's cool, right? That doesn't break any rules. And when we do that, it gives us a different perspective. Multiplying fractions, you do across. 2 times root 3 is just 2 root 3, right? It's like pi. Don't touch it, okay? Root 3 times root 3, well, that's root 9. They're both with roots, so you just stick them inside the same jail, right? Save some taxpayer money, okay? And then we have root 9, which simplifies to, well, if you don't know it off the top of your head, root 9 breaks down into 3 and 3. These are both prime. We put them both in the jail. 3 times 3. One busts out, the other dies. Nothing left over. Demolish the jail. Plus or minus 3. Okay? So what is root 9? Plus or minus 3, right? So this guy becomes 2 root 3 over plus or minus 3. Ta-da! I'll give you some time to digest that. How did that go? It didn't? The one in the final C's here. I had to add a bunch of nonsense to it to make it look different.
Wait, so sine squared beta plus cosine squared beta is not equal to what?
Oh, it totally is.
What? I thought that's what you said.
It's equal to 1. This one's also equal to 1.
Well, that still doesn't help me.
Basically, it allows you to do this over 1, right? Now solve. Okay, so no more trig. Do we understand this concept of how to get rid of the guy in the bottom? Okay, if you forget the plus or minus there, I'm not going to be this stickler about that. It's not huge. And hopefully you know what square root of 9 is off the top of your head. Okay, so The next thing we're going to talk about is our special triangles. There are two of them, which is why I gave you two problems on them. So we have two kinds of special triangles. We have the 45, 45, 90 triangle. Again, those are all degrees we are referring to. So it's a 90-degree triangle, a right triangle, with two 45-degree angles. So this is 45, and this is 45. If the angles are equal, the sides they point to, okay, the sides opposite the angle are going to be equal as well. So this guy, whatever he is going to be equal to this guy. So we can label them both A. This guy right here is C. You could use Pythagorean theorem on this one if you really wanted to, right? A squared plus A squared equals C squared. That's 2A squared equals C squared. If I gave you one of these guys, you could totally figure that out. But that's not the point. What you should be able to do is that if I give you a triangle that looks like something over here, like this, and I tell you that this side is, how about root 2, square root of 2? You should be able to find the other two sides. How? Well, what's special about our 45, 45, 90 triangles is that when the hypotenuse is 1, when this is 1, these guys are root 2 over 2, because they're both equal. And you can figure that out using Pythag if you really need to, right? If C equals 1, and we said we had 2A squared a little bit ago, right? 2A squareds, because they're equal. You simplify that, and you get this, right? This thing inside here. That was awful. Ignore that. You could use Pythag.